let us study the different characteristics of the tangent function. So on the screen, we see the graph of the tangent x. Now, we start with identifying the domain of tangent x. As you know that the domain refers to the possible values of x, which we can use in order to replace variable x in the given function. This is also points on the x-axis at which the function exists. So as you can see in the graph, we can clearly note that there are points on the x-axis at which the graph do not exist. Hence, we can say that it has vertical asymptotes. Now let's identify these vertical asymptotes. Okay, first we have here halfway between 0 and negative pi. Then we also have here on the positive side, we have halfway between 0 and pi, then between pi and 2 pi. Then we have here, okay, and so on. Now let's identify these points at which this vertical lines passes through the x-axis. Now halfway between 0 to negative pi, that corresponds to negative pi over 2. Then we will have 0. Then here we have pi over 2. Pi can be expressed as 2 pi over 2, but take note at this point the function exists. Now the next asymptote passes through 3 pi over 2. Now 2 pi can be expressed as 4 pi over 2. Then here, at which the asymptote passes through is 5 pi over 2. As we continue, somehow you can predict the coordinates, the seesaw of the points at which the asymptote, vertical asymptote passes through. So to have a clear view, we have the following. Okay, let's consider pi over 2. Then we have 3 pi over 2. Now we have 5 pi over 2. Then we can say that we will have 7 pi over 2, 9 pi over 2, and so on. So constructing our description for the domain, we have the set of all x's such that x is not equal to, take note, this numbers pi over 2, 3 pi over 2, 5 pi over 2, and so on are the odd multiples of pi over 2. So we can say that x is not equal to n pi over 2, where n is an odd number. We can also express this as the set of all x's such that x is not equal to n pi over 2 plus pi over 2, where n is an element of the set of integers. This implies the same thing as first. Okay, now we're done with the domain. Now let's have the range. Now, as you can see, the graph goes up and goes down infinitely. So we can say that the range of tangent x is the set of all y such that y is the set, an element of the set of real numbers. Now we cannot determine the highest and the lowest value of the given function. So if we're asked to get the amplitude of tangent x, then we can say that it's not defined. Okay. Now for the period, let's trace how many or what will be the horizontal distance at which we can have one complete cycle. Let's choose this point. So we have 0, then we have this, we trace the graph upward. Then we have here going down. Now I'll stop here. I will not trace anymore the upward or the graph that is going up because it is just repeating this pattern. So in other words, the period of tangent x is pi. So frequency in the interval from 0 to pi is, of course, 1. Okay, so now we were able to describe the different characteristics of the tangent function. Now let's study the different effects of changing the values of a, b, c, and d. Now let's start when we have a is equal to 2. Now for when the value of a changes in the tangent function, we can have or we can describe that the graph of tangent x is somewhat stretched away from the x-axis. Now what if we change the value of b? Let's say we have 2 plus tangent x. What will be the graph? Now here is the transformation. Okay, now let's identify this point. This is the turning point of tangent x. Now in the graph of g of x equal to 2 plus tangent x, we have here the turning point. So in other words, the graph of tangent x is vertically shifted 2 units upward when b is equal to 2. Now what about if the value of a becomes, let's say, -2? Look what happens to the graph. Again, this is the turning point of the original function. And this is the turning point of -2 plus tangent x. So we can say that the graph of tangent x was shifted 2 units downward when b is negative. So we have now seen the effects of changing the value of b in the graph of tangent x. Now what if we change the value of c? So let's say we have 3x, the tangent of 3x. Now we can see that it seems that there is a big change in the graph of tangent x. So let's recall that if we have f of x, the domain is the set of all x's such that x is not equal to n pi over 2 plus pi over 2, where n is an element of this. What about in g of x, what will be the domain? So let's determine this. Let's concentrate on the positive side. So it seems that the interval from 0 to pi was divided into 3. So let's identify this one. Let's identify the coordinates of these points. So this will be pi over 3, and this will be 2/3 pi. Okay, now we determine the vertical asymptotes of the graph. So here we can have the point that is halfway between 0 to pi over 3, then halfway between pi over 3 and 2/3 pi, then we will have here between pi and 2/3 pi, and so on and so forth. Okay, so we can draw a lot of vertical asymptotes in this graph. Now let's identify the points of x, the points at which this vertical asymptotes intersects the x-axis. So halfway between 0 and pi over 3 is pi over 6. Now, pi over 3 can be written as 2 pi over 6. Then this point would be 3 pi over 6. Then this 2/3 pi can be written as 4/6 over pi, 4 pi over 6. Then we will have 5 pi over 6. Then pi is 6 pi over 6. Then we will have 7 pi over 6. Then we have 8 pi here over 6. Then we have 9 pi over 6. Now let's consider here the set of values at which the vertical asymptotes passes through. So we have here pi over 6. Now at the left, we can have a lot of vertical asymptotes. So I will put ellipses here. So pi over 6. Then we have 3 pi over 6. Then we have 5 pi over 6. Then we have 7 pi over 6. Then 9 pi over 6. And so on and so forth. As you can see, there is a pattern. Okay, it's an odd multiple of pi over 6. So the domain of g of x would be is the set of all x's such that x is not equal to n pi over 6 plus pi over 6, where n is an element of the set. Or we can also say the set of the domain is the set of all x's such that x is not equal to n pi over 6, where n is an odd number. Okay, so what about the range? There's no significant change in the range since we still have the set of real numbers for the range in both graphs. So no significant change. Okay. Now what about the amplitude? The amplitude is still the same. We cannot define amplitude since the highest and the lowest values of the function cannot be determined. What about the period? Remember that the period of tangent x is pi. What about the period of tangent x? So in the interval 0 to pi, there are 3 complete cycles in g of x. Okay? In the interval 0 to pi, we can have 3 complete cycles. Let's start. We have 1. Okay. Then another here. I'll use a different color. So 1, 2. Then another here. 3. So that is why we have frequency equal to 3. Now to get the period of g of x, we divide pi by 3. So the period of g of x equals tangent 3x is pi over 3. We can say that there is no vertical or horizontal shift in this graph. So in other words, the change in the value of c has a significant change in the domain of the function and in the period of the given function. Or there is a significant change in the function tangent x. Now we're done getting the effect of the change in the value of c. Now what about the effect of changing the value of d? Okay, so let's try to change the value of d. In tangent x, d there is 0. Now let's try to have plus 2. Okay, now let's see what happens. Now we also change the unit from pi. Let's have 1, 2, 3, 4, and so on. Okay, so that we can see the horizontal shift more, okay, or much clearer. Now, so this is the y-intercept and the x-intercept of the original function. Now, let's study about here. We put here a point. Now, as you can see, it's like the graph was shifted 2 units to the left. So in other words, a change in d will have an effect on the domain, of course, because the vertical asymptotes will change, okay? And it's like the graph of tangent x is moved to the left 2 units. Okay, so definitely there is a significant change in the domain. If you would like to determine the domain of the given function, okay, so in other words, the change in the value of d will have an effect on the domain. Then we have the period is the same, the range is the same, okay? Only the domain has. Hence, we can say that changing the value of d will have a significant effect on the domain. So that's it for the tangent function.